All right, so I think this is recording. Let's take a look here at problem number 1. We have a polynomial function, uh, and we have several parts to this problem. So they want us to select the correct end behavior. So we need to identify the degree of this polynomial and the leading coefficient. First, let's check and see if this is in standard form. The exponents are in descending order, 5, 3, 2, 1, and a constant. So the degree is the largest exponent on a variable, which is 5. And 5 is an odd number. And the leading coefficient is the 4. And 4 is a positive number. So with the end behavior, with the degree being odd, the signs are going to, the end behavior is going to be in opposite direction. So what we're looking for in the graph, with the leading coefficient being positive, it's going to go up to the right. And with the degree being odd, the end behavior is in opposite directions. So as x is going to negative infinity, y is also going to negative infinity. So that rules out 1 and 4. And so between 2 and 3, we need to pick the one that has opposite signs here. So 3 is the description here of this picture, that as you go to the left, you're going down, and as you go to the right, you're going up. All right. The y-intercept, you input 0 into the function. When it's in standard form, it's always this constant term, and that has coordinates 0, -9. Now, to determine the x-intercepts, which are also called the zeros of the function, we solve this equation. You set the output of the function equal to 0. Now, let's fill in a 0 for the x to the 4th term. And then minus 15x cubed plus 5x squared plus 15x minus 9. So we don't have a method that will help us to factor this. The only thing we could basically look and see if there's any greatest common factor among the terms, and there doesn't look to be. But within this table here, it tells us that x equals 1 is a 0, so if you plugged in 1 for x, this arithmetic would result in 0. It has a multiplicity of 3, so we can use synthetic division to help us factor this. So if we use synthetic division, now we're expecting to get a 0 as a remainder down here. If we don't get a 0 here, then something is wrong somewhere, either with our work or with how the problem is stated. You know, sometimes I have accidentally had a typo in the problem. So let's see if that's the case. It should work. And it does. All right, so let's do synthetic division 2 more times. Since the multiplicity is 3, we'll do it again. And again, we're expecting a 0 right here. So we get it, and let's do it again. And again, we're expecting a 0 right here. And we get it. So what this tells us about our equation when we're trying to solve it, that we have x minus 1 raised to the third power, and that this is 4x squared plus 12x plus 9. So now we do have the ability, the toolbox necessary for us to factor this quadratic. We're familiar with a method that they refer to as the X method, which is an organized way to apply the distributive property, which is, this method is the most useful when that leading coefficient is different than 1. So here we're looking for two numbers that when multiplied together give us the top expression, but added give us the bottom. So 36 has a lot of different factors to go through and stuff, but just through trial and error, 6 times 6 will work. So now, whether you guys call chart it or make a table, if we put the first term and the last term along one diagonal, and the two values that we found in our x along the other diagonal, and factor both horizontally and vertically, what we get then is that this factors to 2x plus 3 squared, and if we set 2x plus 3 equal to 0 and solve this, we get a 0 of negative 3 halves. And its exponent is 2. The odd multiplicity meant that we're going to intersect the x-axis by crossing over it. And the even multiplicity, we're going to intersect the x-axis by touching it. All right, so it now wants us, there's a part of the problem that I don't have pasted on here, and that's to select the correct graph. But let's do a rough sketch of what we're expecting the graph to look like. At positive 1, at negative 3 halves, and at negative 9. These are our intercepts, two x-intercepts and one y-intercept. We said that the degree was odd, that we were going up here and down over here. So at the negative 3 halves, it's doing a touch. So it's going to come up, touch this, it's going to turn, it's going to come down, it's going to go through this. Now, we don't know how it's going to turn, but somehow it's going to turn and come up and go at x equals 1, it's just going to cross over this. So this is roughly the graph that we're looking for. The things that we know for certain are the end behavior, the intercepts, but we don't know how this is coming down. We don't know if this could come down and then come up through there. We don't know if this could come like this and come and go up. We really don't know the shape of the middle portion there. Let's look. Do I have the, yeah. Let's see if I can get this so that we can look at it. Yeah. All right. So it can't be, it's going up to the right, so it can't be 2 or 3 because those are going up to the left. Number 1 is going up to the right, and number 4 is going up to the right. It's going down to the left. Now, on the left here, we see a touch, but over here we see a cross. And so here, -3/2 is about -1.5. So it has to be this choice of number 1. All right, so I hope that helps. That was the last part of it, wasn't it? Yeah. Hope that helps, and I'll talk to you later. Bye.